Greetings everyone. We will continue our discussion on object-oriented programming through C++. In the previous session, we have started about the key concepts of object-oriented programming. In the particular key concepts of object-oriented programming, we have looked at various topics. In this particular session, we will complete those key concepts of object-oriented programming. After that, we will be looking at what are the various object-oriented languages we have, and also we'll be looking at the introduction to C++ programming part. Okay, in the previous session, we have looked about what are objects, what are classes, methods, and more specific concepts of object-oriented programming, that is data abstraction, encapsulation, inheritance, polymorphism, dynamic binding, and message passing. In this particular session, we'll be looking at the remaining three key concepts of object-oriented programming. So a brief review, I told you about what is data abstraction. It is hiding the important and implementation details and only showing the necessary details to the user. Will be calling it as data abstraction. Next, I told you about the encapsulation, where you are going to keep both the data and methods which operate upon the data in one particular thing called as the class. That we will be calling it as encapsulation. I told you about the inheritance, where the child classes can inherit the properties of the parent class. This provides the concept of reusability. We will be seeing that in this class. And polymorphism, as I told you, a particular function or an operator taking more than one forms, we will be calling it as polymorphism. In this particular example, the draw method is taking more than one forms. That is why we will be calling it as polymorphism. And dynamic binding, that is the particular binding part which will happen during the execution time of a program, we will be calling it as dynamic binding. And message passing, in order for the messages to communicate with one another, we will be using the messaging part, where one object communicates with other object through messages. And also the last three particular key concepts of object-oriented programming. So the first one, reusability. So object-oriented programming allows reusability of classes by extending them into other classes through inheritance. While discussing inheritance, I told you about a parent class and we will be having a child class. So the child class will inherit the properties of your parent class. So whenever this inheritance is happening, we are basically extending the properties of your parent class. Whatever may be the parent class properties, all those properties can be extended by your child class. Okay, that is why. So this particular code or the class or object, whatever you are writing for this particular thing, those objects can be reutilized by the child class. So this process of using your already existing code, will be calling it as reusability. So once a class is defined, the other programmers can use it in their own programs. Okay, once if you define a class, that particular class can be reused by other programs as well. So whenever you are writing object-oriented programming, first we should check whether the particular objects are already written in other codes or not. If they are present, we can reuse them. So this particular reusability is present in procedure-oriented programming also, where your functions can be reused by next functions. But in object-oriented programming, the classes we write and whatever the objects we create, those particular classes can be reused or extended in a further particular classes through inheritance. Okay, next, the programmer can also add new features to the derived class. So this is your parent class, this will be child or your derived class. So the parent class will be having its own properties. Okay, these properties can be extended by your child class. Apart from this extended, it can add new properties, its own particular properties. I show you the example in your particular bowling class. Okay, so the bowling class will be parent class, your child class will be the particular child classes. The child classes can extend the bowling class, okay, or your parent class. Apart from the extending part, it can add its own features. So this thing will be calling it as reusability. That is, using the already existing code. So this is an example of reusability, as I told you. So your particular parent class here is your account class. The account class has two methods, that is the deposit method and your withdraw method. So initially you have written an account class. That account class has two methods, deposit method and withdraw method. So whenever you are writing a code for two other classes, that is savings class and checking class. Okay, during this particular instance, savings account also will be having the both operations, that is withdraw operation and deposit operations. Your checking account also will be having both deposit operation and withdraw operation. During this instance, you need not write the code again here. Okay, instead of writing the code again for your deposit and withdraw, okay, you can just extend this particular thing. That is, this particular saving class and checking class can derive the properties of your parent class, that is your account class. Okay, so this particular savings class and checking class, whenever they are created, they can extend this particular account class, so that this will contain your deposit and withdraw method, and this can also contain the deposit and withdraw method. Apart from these two methods, it can have its own methods for your particular classes. Okay, so this is how we are reusing the already existing methods present in a previous class. So parent class are having some functions of deposit and withdraw functions. No need for the child class to define them separately. You need not define them separately in the child class. That is what we will be calling it as reusability, or reusing the already existing parent class. So this is the important feature of your particular reusability. Basically, reusability is implemented by using your inheritance in C++ or object-oriented programming. The next one is delegation. In object-oriented programming, two classes can be joined by using two ways. One is inheritance and another one is delegation. You have seen inheritance, how you can extend one class into the another. Okay, there is a process to combine more than one class into the thing. That is, there will be another various types of inheritance, where you will be having first class A, another class B. You can acquire the features of both class A and class B into class C. Okay, so you can acquire the properties of A as well as you can acquire the properties of B. So for C, we are having two parents here. Okay, these two are parent classes and this one is a child class. In this manner, you can join two classes into a third class. Okay, so inheritance will be used or can be used to join two classes. Apart from this one, there is another concept called as the delegation, which will be used to combine or join two classes. In inheritance, one class is derived from the other class. This relationship we will be calling it as a kind of relationship. Okay, the delegation object of one class is used as data member in another class. So how we are going to basically implement delegation is, so we will be having one class A. Okay, so using that class we will be creating objects. Okay, we are creating one object. The delegation part is, you are having class B. Inside this class B, you are using the particular object A. Okay, this part, that is using the objects of another class in this particular class, we will be calling it as delegation. Okay, delegation object of one class is used as a data member in another class. Okay, delegation is the process of using this particular thing. So if you see, this is an example of delegation. So the first one, we are having one class point. Okay, this is a class point, and we are having another class line. Inside the class line, you have declared two objects of this point class. That is point class. Using the point class, you have created two objects, point P1 and point P2. Now we are writing 2 points here. Okay, so inside the class line, we are declaring two objects of the point class. This thing, that is using the objects of one class inside the another class, we'll be calling it as delegation. So in this particular line, so you can see here, if you see class line color extends line. So this is inheritance. Inheritance involves extending. So this thing, line color, is now the child class and this is the parent class. Okay, this is your child class. So in the child class, we are extending the particular parent class. So this is inheritance, where the child class is extending a parent class. This part is delegation, where you are using the objects of another class in the particular class. Okay, so there are two ways to combine classes. One is inheritance, where you are extending the parent classes, and another way is using the objects of your parent classes. Okay, so this is delegation. So using this method, we will be using in future particular sessions. For the time being, know that delegation is using the objects of another class in this particular class. That we will be calling it as delegation. In this manner, you can combine two different classes. Okay, so you are dealing with combination of two classes using inheritance and delegation. The next one, genericity. So the software components of a program have more than one version depending upon the data type of your arguments. So whenever you are writing one particular software or small program, so that particular program might work for one set of data types and it might not work for another set of data types. So genericity feature allows declaration of variables without specifying the exact data type. So you will remember, without specifying the exact data type. So basically, genericity features provides that you can write a program which is not related to one data type. Okay, this particular program, whatever you write, which will work on any data type. So genericity will be mainly about writing a program which will work for any data type, not just for integers, not just for floating point values, not just for double. Whatever may be the data type supported by particular programming language, all those data types can be working for that particular language. Okay, so in the operator overloading, I told you, if you want to write something like this. So if you want to find the square of an integer, we have to write one code. And if you want to find the square of a floating point number, you have to write another code. Okay, you have to write two functions for the same purpose, that is to square a number. So you are writing two functions. This is also what we will be calling it as function overloading. So function overloading also involves large amount of programming. To avoid this one, we will be using the genericity feature, where instead of writing two functions, we will be writing only one function. Okay, where T will be treated as a template. So A will be treated as one template variable. Template variable means it will be acting as any data type variable. Okay, we will be looking at them. So the compiler identifies the data type during the execution time or runtime. So when you write program in this manner, and if you try to calculate the square of an integer, it will try to find the particular, what we call it as the data type of the number during the execution time. And if I try to calculate the square of a floating point number, it will try to execute the particular thing during the execution. You will be writing only one code instead of two codes here. That is genericity. So whatever the code you write, it should work for all the data types, not just for integer and floating point. It should work for double and other also. Okay. So I will show you an example regarding this genericity. So in this particular example, we have taken maximum of two numbers. So first look at the main program. So inside the main program, you have called maximum of 3, 7. Okay. Here you have called maximum of G, E. So here you are specifying what is the data type of what you are going to do. That is, you are specifying that 3 and 7 are integers. So this particular max should work for integers. This particular max should work for character values. when this happens, remember, this is another thing, your basic code is only this one. So your code will be this manner. So when I call this function, this particular function will jump from this place to this place. This is your function prototype, where I am declaring one template. Templates are the ones which will be used to implement your genericity in your particular language. You will be learning about the templates in the last units. For the time being, know that in order to implement the genericity, that is writing programs for every data type, we will be using the templates. So they will be writing a template type name T. So when you declare something like this, we are saying that we are using templates in this particular program, and the particular template is T. T means it will represent any data type. So I am writing a function max with two parameters x and y. So if you have remembered, we will be writing int a comma int b, but we have written tx comma ty. Now it tells that this x is one integer or variable, that is a template variable. Template variable means it will represent any data type. Ty means y also will represent any data type. And the particular thing, operation will happen and it should result the particular data type. T means it will represent any data type. If I am working on integers, it will return an integer. If I am working on floating point values, it will return a floating point value. So whatever the particular thing you specify here, the particular result will be present. So in the background, what will happen is, when I call this particular function 3, 7, so the code will be taken in this manner. The compiler internally generates and adds this particular code. So when I am calling it with an integer, it will generate an integer code. When I am calling with a character, it will generate a character code. So this particular thing where you write a code or a function for every data type, will be calling it as genericity. Okay, this is another important feature of your object-oriented program. Okay, so before going to your object-oriented languages, I think you can understand those are the key concepts of your object-oriented programming. So right from your objects, classes, abstraction, okay, encapsulation, polymorphism, inheritance, your genericity, message passing, okay, all these things are the most important concepts of your object-oriented programming. All these concepts are generally present in most of the languages, but few languages will be skipping some of these particular things due to implementation issues. Okay, some languages will support some types of inheritance, some languages will not be supporting polymorphism, like this. So you have to remember that, okay, whatever the language you try to study, you have to find out what are the features present in the particular language before going into depth about that particular language. So your C++ will support all the particular 12 key concepts I have mentioned so far. Okay. So whatever programming languages I mentioned in the next slide, most of them will be supporting most of these particular key concepts, but few it will be skipping. Okay. So object-oriented programming languages are very diverse. Okay. And many of the most widely used programming your object-oriented programming languages, such as your C++, Java and Python, these are your object-oriented programming languages, are usually multi-paradigm languages. Okay, all the most widely used your object-oriented programming languages, that is C++, Java, Python, these three or other major languages what you are listening generally in the market are usually multi-paradigm languages. Multi-paradigm languages means they will be supporting multiple paradigms. That is, I told you about the 4 paradigms, that is monolithic programming, structured programming, procedure-oriented programming and object-oriented programming. Okay, so your C++ is usually both procedure-oriented as well as object-oriented. Okay, it will support both the paradigms. That is why C++ will be calling it as multi-paradigm language. In the same manner, Java also will support both procedure and object-oriented languages. Okay, these are not purely object-oriented languages. There are many other languages which are purely object-oriented languages, But these are very popular. Why? Because they have taken the advantages of your conventional programming languages, and they have taken the advantages of object-oriented languages and combined them to form a strong language. Okay. So all the major languages which you are seeing will be multi-paradigm languages. They are not purely object-oriented languages. They are somewhat having some degree of combination with your imperative procedural programming languages. So other major particular object-oriented programming languages are your Java, C++, C#, Python, R programming, PHP, Visual Basic, .NET, JavaScript, Ruby, Perl, Object Pascal, Object C, Dart, Swift, Scala, okay, Kotlin, Common Lisp, MATLAB, Smalltalk. Like this, you are having numerous number of object-oriented programming languages. Some of these particular languages are purely object-oriented languages. That is, you will not be looking at anything other than objects there. Whatever code you write, you have to write in classes and objects only. But in C++, we will be combining both your procedural-oriented language as well as object-oriented language. That is, whatever you have written in C language can be written in C++ quite easily. But implementation of objects also will be done in your C++. That is why it is object-oriented programming language. So whatever you are looking at here, as you could see, your C++ will act as a base to lot many languages. So whenever you learn the C++ language, you will be getting the foundations of many other languages. It will help you in the future to learn whichever language you want based upon the application or based on the area you want to go. So this is the outline about the programming languages or your object-oriented programming languages you have for the learning. The next thing, this is an introduction to C++ program. So this is a basic example of a C++ program I have given. So this here I am giving you this particular thing to give you an idea about how your C++ program will basically look like. How your C and C will be different. Okay, the first thing, the first line, whatever you are seeing, you are writing hash include IO string. So in C language, you usually write hash include stdio.h. So basically to specify standard input output functions. So here also you can write hash include iostream.h, which is also a header file, but in the modern versions they have removed the .h extension. Now currently we will be writing hash include iostream only. So this particular containing the input and output functions in a particular header file. Okay, in C language we will be using stdio.h and in C++ we will be using iostream.h. And the second line of code is namespace std. We are having separate. We will be having separate discussion on namespaces. For the time being, know that namespaces are used to create a separate environment for your programs. Okay, whatever program you are writing, you are creating a separate environment called as the standard namespace. You will be learning that about it clearly in the future classes. For the time being, know that it is something called as a standard namespace, where whatever you give, the names should not collide. That is why we will be calling it as namespaces. And as you go down the program, so we will be having int main. So in C language, even if you don't specify the int, it will be automatically taking it as void. But in C++, you have to specifically specify your particular return type of your main. Okay, in C language, even if you don't write, it will take it as by default void. But in C++, you have to specify the return type of your main. And next, just like C, you will be having your declarations of your int. Okay, integer declaration int I. Next, you are having something called as cout. Cout will just act like your printf statement. Cout will act like your printf in C language. In C++, we are using the cout, that is cout object, and whatever the contents you want to print it on the screen, you can write between the quotes. Okay, so here you need not specify your access specifiers, that is percentage t, percentage of. If you want to print a number, you need not specify those access specifiers, but basically instead of printf you are using cout. And just like C language, you can use a single line comments by using // or multiple line comments by using */ and ***, and we will be using the single line comments. After that, we are using the cout to print enter a number. Then instead of scanf, you are using something called as the cin. Okay, in C language you have the scanf for input function. Here we have cin, and the output is printed by using cout I, whatever the value you are printing I, that I value will be printed here. I squared is, and you are printing the I into I here. Okay, so this is how we will be printing one single line of statement using cout, and you are not having access specifiers to print. Directly you will be specifying the variable without any access specifiers. So we will see in more depth about all these particular C++ programming parts in the next class. So we are looking at what are the various programmable structures you have which differ from C++ to C. Okay. In this particular session, we will conclude this particular session. In the next session, we will be looking at some more parts of the C++ programming. Thank you.